Hi, everyone. So today we're going to jump in to the Essentials book, and we're going to do sort of the first chapter and part of the second chapter, focusing on the idea of definitions, measurements, and variables. I had scheduled a video for Chapter 6 in Deciding Social Inquiry, but considering that chapter is on critical case studies, and I actually think it's very well done, I don't think there's a need for me to do a video on that chapter. So we're going to go into essentials and get this discussion knocked out for the week. So the first thing we're going to talk about is sort of defining a concept. And we need to really understand that there are very few things in political science that are very simple to define. Many of the concepts we deal with, many of the ideas that we deal with in political science are multidimensional, are complicated, and as theoretical creations are sometimes difficult to get a grasp on. So we follow a very systematic fashion by which to define concepts and also operationalize concepts. So let's take an example. First off, democracy. So what is a democracy? How would you describe a democracy? In what context what would you differentiate from a democracy to an autocracy or an oligarchy? This concept, just thinking about it in your head, you can see multiple sort of dimensions to it, multiple ways to think about how we would define the concept of democracy. But in terms of a research methods class, we also have to take another sort of layer into consideration, and that would be what indicates that a democracy exists. So if we were to take a country, what is it that we would precisely look for us to say that that country is a democracy? So the answer to the first question of what is democracy would be what we call conceptual definitions. The answer to the latter question, how would we identify or indicate that democracy actually exists, that is actually an operational definition. And those two pieces of defining a concept are necessary to sort of move forward in research methods in political science. So let's take a deeper dive into conceptual definitions, because conceptual definitions do a few things that are important for us because they sort of define the realm of what it is that we're attempting to explain. So the conceptual definition allows us to boil down a construct or idea into three basic parts. First, it identifies the concept itself, it identifies the level of analysis, and it identifies what we intend to measure, not exactly how we're going to measure it, but what we're going to measure. And it follows a formula. And here's that formula for democracy. So the concept of democracy is defined as the extent to which countries exhibit the characteristics of allowing their citizens to choose their own leaders through elections. So you can see I underlined sort of each of those steps. So the concept itself, the first underline, is democracy. The level of analysis, so that what we're looking at, another way to think of that is what are our cases? Countries. We're looking at the concept of democracy through the lens of countries. And what we intend to measure is the idea that individuals are allowed to choose their leaders through elections. Now, we haven't indicated how we're actually going to do that. But we've at least gotten a definition of our concept, which allows us to build upon to the next step, the operational definition, in which we are going to define how we're going to operationalize that variable, how we're going to operationalize that concept, and actually measure it. So an operational definition is the way in which the research is going to measure the concept that we created in the conceptual definition. So we have to come up with a way by which to identify democracies and the concept of democracies based on countries. So we've identified the concept, democracy, we identified the level of analysis that is countries, and we've sort of identified what it is that we're attempting to seek out when we want to say that a country is a democracy, and that's individuals have the ability to engage in elections to choose their leaders. Now we have to come up with a way to actually measure that portion. And much debate in political science has gone on in the idea of how do we measure whether or not a country has democracy. I chose one of the most frequently used, and you can see how it actually takes all of those parts of the conceptual definition and boils them down into something that we can actually measure. So, for the purposes of this study, countries will be considered democracy if they have had 2 turnovers in power in either the parliament or the presidency and maintained regular elections. So what this operational definition does is it carves out the way in which we're going to identify a democracy, and it does so in a meaningful fashion. So if a country regularly has elections, but power is never transferred to another entity. So the same party remains in power for 60 years. It's hard to call that country a democracy because there hasn't been a successful turnover of leadership. One of the defining characteristics that we think of a democracy is being able to have regular elections in which the opposition party or an opposition party takes power. So this operational definition sort of gets the core of that. They have to have had 2 successful turnovers in power and maintained regular elections in order for us to call that country a democracy. Now, is this the only way in which to measure the concept of democracy? Absolutely not. And we'll employ other measures in this course. But this is a simplistic operational definition that attempts to measure the concept. Does it measure all of the concept of democracy? Absolutely not. We could say that part and parcel to being a democracy is having a free press. This operational definition does not even touch upon that part, that dimension of democracy. It touches on a dimension of democracy, which we've identified as being important and therefore buttressing our conceptual definition. Now I want to transition in terms of measurement error. In our last video, we talked a little bit about measurement error, but I want to go over it again because measurement error is vastly important in the social sciences, especially political science. And we've already talked about the 2 types of measurement error. That's systematic measurement error and random measurement error. I want to talk and give some more examples about what those actually are and what to look out for when you're doing sort of data analysis. So systematic error introduces a chronic and constant bias into measurement. So this is something that is systematic within the entire data set and has and equally and evenly and consistently applied to every time you take a measure. So what would an example of this look like? Well, let's say we had a math test and that math test had on the key had wrong answers. So when the instructor went through and graded it, answers would be marked incorrect that were actually correct. That's a chronic and systematic bias. It is across the board. Every student that answered the test correctly would be marked with the wrong answer. That is systematic bias. It differs from random error. So random error is haphazard and chaotic. It is not applied in any systematic way, and it makes it exceedingly difficult to assess any sort of relationships within the data. So what would random error look like as an example? So let's say, for example, we gave that math test. And one thing you have to understand is that the goal of the math test, or the goal of any test, is to be able to assess how much an individual knows. So with the systematic error, we're systematically docking individuals who answered correctly. So it's across the board. So the actual device is flawed. But let's say we have a test that is free of systematic error, meaning that the test is written in a way that is easily understandable and the answer key is actually correct. So what would random error sort of look like in that? Well, let's say, for example, some students showed up and took the test drunk. Let's say they're really bright students that did something stupid on test day, and therefore our device, which is attempting to measure how much they know, fails because of random error. So it's not systematic across the class. It's a few students in which the actual device does not measure their knowledge as accurately as others. So that's what random error is. Now, what are sort of the fallbacks? What are the downsides to systematic measurement error and random measurement error? Well, we have to introduce two concepts to understand that, and that's reliability and validity. So reliability is how consistently that measure is applied. So reliability of a given measure is affected significantly by random measurement error. Think about the reliability of a test in order to assess whether individuals know a concept. If it does well for some students and doesn't do well for others, then that's not a reliable test. But if you introduce random measurement error, even the most reliable device will have problems. So the example I previously gave, the test itself attempt to accurately assess the knowledge of the students, but a random error was inserted, and for those particular students, it did not assess reliably their knowledge of what they were being tested on. That's problematic. Also problematic is validity. So validity is how well a device measures the concept. So if the test was to, again, assess what you know, but there exists systematic error within it, then we're systematically on certain questions not able to assess how well you did, then that measure may not be valid. In terms of examining causal outcomes, low reliability is much more problematic than low validity. And the reason for that is we can't assess whether, let's say, for example, hours studied predicts how much you know on the exam if there exists random error in the assessment of how much you know. If there exists systematic error in assessing how much you know, that doesn't affect assessing causal relationships. So in terms of what we're doing from here going on, we're worried much more about the reliability of a measure than we are the validity of a measure, though both concepts sort of get at the core of what we think about when it comes to measurement. And this is why most social scientists spend a great deal of time attempting to craft and create measures that are both reliable and valid. So we've sort of danced around this concept, but now we're going to get to the core of what the majority of the rest of this class is going to be about, and that's assessing relationships between variables. So let's go ahead and talk about what a variable actually is. At its most basic level, it is an empirical measure of a characteristic. Now that characteristic ties to a concept that is backed by an operational definition. So the variable itself exists because it operationalizes or gives us the context of measurement of some concept that we wish to examine. So variables a lot of times are simplifications because of the way we operationalize them. Now, there needs to be some defining characteristics in order to have a variable. To do this, we absolutely have to observe something that varies. That's what that's what variable means. We observe a operational concept that varies. There are really a couple ways to do this. There are lots of ways to observe something. Surveys, looking at country codes or country reports, designing your own study. There are lots of ways to observe concepts that vary, to create a variable. But we need to know that every variable that we are looking at by just has to have two observable values. So when we're attempting to measure a concept, we have to have at least two observable values because without two quantities in a variable, we can't assess differences. We're simply unable to statistically. When we get down to this concept of variable, we have to think about how we measure this variable. And there are largely in the social sciences 3 levels of measurement that we consider. Now, these measures vary in terms of their degree of precision. And precision we should think about in terms of how accurately we measure our concept. So at the highest level are interval level variables, often called continuous variables. These are the most precise. They measure concepts like income in dollars, age in years, approval rating in percent. These sorts of things offer a degree of precision that are higher than the other 2 because they measure a concept which can be easily quantified in the fashion by which that we want. Second are ordinal variables that are less precise, but still generally provides us measures of concepts on a scale. So think about this in terms of approval or disapproval. Approval versus disapproval. So do you approve of the job that the president is doing? You either say, I approve or I disapprove. Well, that is a scale of approval. It's not super accurate. It's not very precise, but it does have movement. It does provide us in terms of we can talk about differences, not meaningful differences, not quantifiable differences, but we notice that there is a degree in that range, and we can talk about the difference between someone who approves of a concept and someone who disapproves of the concept, knowing that the distance between them does talk about a degree of movement of a concept. Now, lastly come nominal variables. And nominal variables by their definition, or by the definition of what they are least precise, because nominal simply means name. We generally think of nominal variables as what are known as indicator variables. So they indicate the presence of something. One of the most frequently used is gender. So when we're talking about survey research, gender is an indicator variable. Because more often than not, perhaps even inaccurately, we measure gender in a simple binary concept, male versus female. Now, an individual who is male does not have any more gender than an individual who is female. There is no directionality in there in terms of gender. The difference is not a quantifiable thing, but it does indicate differences. Another example would be religious affiliation. Catholic versus Baptist versus Muslim versus Jewish. None of those people who identify as being of that religious affiliation are, by definition, any more religious than someone else. We're simply identifying, indicating a concept. And so these nominal level variables may actually be the most precise way to actually measure those concepts by simply identifying them. But because of the lack of difference in terms of measurable differences between the categories, we think of these as the least precise units of measurement that we use in social science. So a little bit more about interval variables. First off, they communicate an exact amount of a quantity. So when we talk about, when we look at a data set, or we think about the concept and we want to measure age, that age is communicated in a precise amount, though it might vary in terms of that preciseness. So for example, I'm 41 years old, but I'm also not. I'm 41 years old some months and some odd days and some on hours and some on minutes and some on seconds. So the most precise way we can measure that probably isn't the way that you're presented that data most often. I would simply say I'm 41 years old. But we know exactly what that quantity means. And we also know that if one of you responded that you were 22 years old, we know that the distance between 41 and 22 is meaningful. And we also understand what that difference means. So we get the distance between objects is absolutely meaningful. So when you can look at a variable and look at the distance between quantities, the distance between respondents, or the distance between cases on a given measure, and that quantity of difference is actually meaningful, then we can identify very easily an interval level variable. An ordinal level variable, we can identify differences between cases, but the distance between those cases on that given variable is not easily quantifiable or meaningful in a substantive way. So these ordinal variables, the values of the variable communicate the relative amount of the concept being measured. They don't indicate a precise amount of the concept being measured. And therefore, those differences between cases isn't exactly a meaningful quantity. So we can compare those different quantities, but not in any way precisely. So let me give you an example. If I approve of abortion under certain conditions, and you approve systematically, and you think abortion of all types at all times should be legal, we know that there is a difference there. There's a difference between my opinion and your opinion. I approve of less abortion than you do, or you approve of more abortion than I do. But the difference between my case and your case is not precise, because we could largely and very easily conceptualize an individual who also approves of abortion, but under very limited conditions. Let's say only for health and safety of the mother. Well, that's less than me and less than you. And I'm in the middle, but the distance between me and you is not a meaningful, quantifiable concept. So ordinal variables are ordered in that way, where they measure relative amounts of a concept, but the distance between those points is not meaningful in a sense of a precise quantifiable portion, but we can say that someone has more or less of something, or a country has more or less. We can assess differences in that way, but not in a precise sort of way. And lastly, nominal variables. Largely, they communicate identity differences between cases, whether an individual is male or female, the race of a respondent, whether a country is a democracy or an autocracy or an oligarchy. Those are sort of identity-based differences. So the difference between cases is not quantitatively meaningful, but the naming of them is meaningful. When we say country A is a democracy and country B is an autocracy, there isn't a meaningful difference between them. We've simply identified a characteristic of them. Let me provide you a more precise sort of example, and this is where we'll sort of leave off for the day. Next week, we're going to be talking about how do we actually measure these concepts, and not just how do we measure them, but how do we describe them after we measure them. So we're going to talk about measures of central tendency, and we're also going to go through, for the first time, static commands and sort of assess these things. So we're actually going to learn how to get into the software and work with it, just as a foreshadow. But back to this idea of nominal variables. Let's take it a variable that measures religious affiliation. Let's say we have 3 people. And in that group of 3 people, we have 2 individuals who identify as Catholic and 1 who identifies as Muslim. Those 2 individuals who identify as Catholic have that in common. They are both Catholic. And the individual who identifies as Muslim is Muslim. And that's all that variable signifies. There are other concepts that we can measure. Let's say how more religious an individual is over another. We can measure that, but this identifier variable does not measure that. And so we need to be at least somewhat careful when dealing with nominal variables to not try to make them do more than their precision allows us to do with them. So a variable that measures gender, a variable that measures race, a variable that measures religious affiliation, all of these things are indicators. They indicate an identity. There may be concepts underlying those that we're very, very interested in, but we would have to tap them with another variable. Still, these nominal variables can prove exceedingly valuable in explaining differences. But they're not very precise to measure concepts in and of themselves, even though they prove to be in final analyses exceedingly important. So next week, the video will look a little bit different. May have some slides. Mostly it will be me going over and talking about how to use Stata and how to apply the concepts from the Essentials book to the concepts of the companion book. And I will go through the companion book and make sure, at least in the video, that you can do all of the homework that will be assigned out of the companion book. So through reading the book, reading the Stata companion, and watching my lecture, you should be able to next week accomplish all of the homework that's assigned to you. All right? Hope everyone has a good week. Any questions, please post to Blackboard, and I'll talk with all of you soon.